Okay, we're gonna create a Cassandra cluster, and we're gonna use Docker and blockade. So we're showing the blockade YAML file. We have a Cassandra 1, Cassandra 2, and Cassandra 3 node. The Cassandra 2 has Cassandra 1 as a seed, and Cassandra 3 has Cassandra 1 as a seed as well. This is commented, so we will just have 3 nodes. Okay, so in order to start our cluster, we do blockade up, and we see that we have like Cassandra 1, 2, and 3, and they are all in the same partition. In order to connect to the nodes, what we do is Docker enter, and then the container ID. So we're connected to the first node. Then we copy the second node's ID, and we do Docker enter and the ID, and we do the same with the third node. We're going to open a Cassandra shell in the 3 nodes. Okay, and we're going to show now the schema of our data. We'll create a table and insert data into it so that we can do something with it. There are 2 rows, 2 different values for $1, and we're gonna see. We're gonna visualize that table now by selecting everything. Oops. Okay, so that's what we have. We have a timestamp, a column, which is the $, and a value which is 1.1 and 1 at different moments. And we're going to change the data now. We just want to show that if you change something on a node, you'll see it immediately in the other nodes. Which is the default, it's the normal behavior anyone would expect. Nothing weird so far. So we changed the data in one node, in node 3, and we see the changes in node 2 and now in node 1. Now we're gonna make a partition. We're gonna isolate node 3 from node 1 and 2. So this is our cluster status. There is a command blockade partition. And we'll give the Docker ID, but it doesn't work. So I'll give the Docker name. Probably that's how it works. Sorry, I said Docker partition, I meant blockade partition. So now we have our third node in a different partition. We have partition 1, which contains node 3, and partition 2, which contains node 1 and 2. So if we make changes to node 3, these changes won't be reflected on node 2 and 1. And if we make changes in node, you see how data changed in node 3, but it didn't change in the other 2 nodes. So they are completely isolated from each other. Yeah, if we once we join the 2 partitions, Cassandra will take the data with the latest timestamp. Cassandra has internally a timestamp for all of its rows. So if there is a conflict, because I modified the same data in 2 different nodes, when we put everything together, it will check the latest timestamp, and it will that data will prevail. So now we changed the data in node 3, and now we changed it in node 4. And if we select in node 4, oh well, we didn't join. Yeah, we need to join. So we have different data in different partitions so far, which is normal. And now we joined. And now we should have the latest data in the whole cluster. So let's see. Yeah, we have, so the cluster is alright, everything is in the same partition. So we have, yeah, we have the same data in the 3 nodes. So the latest data, or actually the data with the latest internal timestamp is the data that we prevail. So yeah, I mean, we will make another video with desynchronizing the clocks, but it's difficult to do with Docker. So we'll make like we'll use real nodes in different machines. So we'll use VMware or something like that, which actually isolates nodes better. But that will be a second video.